is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Multicolored Digits. This is my first module I actually made and actually coded and modeled and whatnot, so I'm going to be teaching you guys how to do this module today. Now, of course, this module itself is very self-explanatory and actually very easy to do, but I'm just doing it because I like tutorials. So, let's get right into this. So on the module, what we'll have here is a display that will have a series of different digits, a stage counter on the right side, and obviously our buttons here to input, as well as a clear and submit. So the middle display is going to be our screen that we're going to submit on, and we're going to be trying to alter these digits based off of the colors that represent each of these colors. So what we have here is for table 1, we have a series of different colors, which include red, green, yellow, blue, white, magenta, cyan, orange, purple, and of course gray. So let's take a look and let's see exactly what we need to do here. So the number on stage 1 will have 3 digits, with the amount of digits increasing by 1 with each completed stage, all the way up to stage 4, which contains a 6-digit number and an extra procedure, which will be explained in the next page. We'll get to that when we get there. So essentially what's going to be happening here is we're going to essentially be treating each individual digit as its own individual digit. If there happens to be 2 or more adjacent digits that have the same color, we're going to treat them as separate digits and not a single number. So every single digit in this display is going to be its own separate entity. That's basically what we're going to be working with here. And if you happen to get a case where you happen to have leading zeros, for example, that is totally fine because that's part of the solution, technically speaking. So this isn't like submitting a number, for example, say if you got 049 instead of just submitting 49, that's not going to happen. So just keep that in mind, that there is the possibility of leading zeros. It's very important to do that. And this is supposed to say 4 stages instead of 5, so we'll fix that real quick. After typing the new number, press submit. Submitting a wrong answer will obviously result in a strike, and a new number is not going to actually be generated. It's going to be the exact same number as far as I'm aware. So I'll fix that as well. And we're going to use the clear input to erase the current input. So what's going to happen here is there's going to be a series of alternations that is going to be happening with each individual number based off of its color here. So for our first one, we have green, which is a number 1. So green wants us to add 1 to the digit, and 9 loops to 0, and 0 loops to 9, etc., etc. And in the cases where it says use LSD, no, it is not referring to the drug, unfortunately. It is referring to the least significant digit, as it mentions down here with this asterisk here. So for green, we want to add 1 to the digit. So in this case, 1 plus 1 is going to be indeed 2. Very simple. Next up, we have purple and 3. We're going to subtract the digit from 9. So it's going to be 9 minus 3, which is going to give us 6. Then we're going to do cyan 3. Cyan is going to be subtract 2 from the digit, which is going to give us 1. We're going to hit submit. And just like that, that is good to go. So now we're on to the second stage, and as you can see now, it is 4 digits long, each increasing by the number in total increasing by 1 digit. Green is going to add 1 to the digit, perfect. Cyan is going to be subtracting 2 from the digit, so we're going to do 5 here. Yellow is going to be subtracting 1 from the digit, which is going to be a 2. And cyan is going to be subtracting 2 from the digit, and remember, in this case, we're going to go to -1 if we do subtract 2 from this number, but in this case, we're just simply going to loop to 9. That's just the way that works. So this is now going to be, instead of -1, this is simply just going to be 9.
Very well done.
That's good to go. So now next up we have orange. Multiply the digit by the number of batteries. So there is some cases where we actually are going to be using edge work in this case. This is actually the only one that we want to pay attention to. So for right now, this is there's no batteries, so that's just going to be a multiplied by 0. Anything multiplied by 0 obviously is going to result in 0. And obviously, if it were to go above the 10 mark, for example, you would simply just use a least significant digit or modulo this by answer by 10. So green, we're going to add 1 to the digit. It's going to be 8. Cyan, 4 is going to be subtract 2 from the digit. That's going to result in 2. And one thing I should mention, obviously, is the colors of the buttons are irrelevant. They're just kind of a module design that I wanted to make. Orange, we said that there was going to be multiplied by batteries, so there's going to be 0. And magenta is going to be adding 2 to the digit, which in this case is going to be 4. Okay, now we're at stage 4. And now we have this little special feature, the question mark. And this is where we're going to have to use the second part of this manual in order to actually determine the answer for this one. So all of the other numbers are going to be represented the exact same way. They are going to be treated as normal in the first table here. But we need to determine what the question mark actually is and what its color really is, because the color that it actually is currently displayed as, in this case orange, is not necessarily the color that we're going to be using for the altercation here. That's going to be one thing that we need to note down. So, for starters, what exactly do we need to do? So during stage 4, one of the digits will be replaced with a question mark. The color of the question mark is irrelevant, as I just mentioned. We're going to use table 2 to determine the digit and its color. The row is determined by the least significant digit of the sum of all digits except the question mark before changes. So what we need to do is we need to note down, we need to sum up everything in the current display, not including the question mark, of course, because that wouldn't make sense. We need to sum up everything that appears up in this display, and that's going to be our row before the changes. Now what we need to do for the column is determine by the least significant digit of the sum of all digits after the changes, except the question mark. So we need to do a before and after for all 5 digits, and that's going to be determining our row and column for the table. So for starters, our row is going to be 3 plus 3 plus 9, which in this case is going to be a total of 15, or simply 5. And that's going to be our row right here. Then, for our column, let's actually work out all of these digits and see what they are. So red 3 is going to be leave the digit as is. Okay, perfectly fine. Green is going to be adding 1 to the digit. So in this case, that's going to be a 9 plus 1 is going to be a 10 or simply 0. So there we go. Obviously, the question mark is the question mark. Yellow is going to be subtract 1 from the digit. That's going to be 0 minus 1 is going to be going back to 9. Purple is going to be subtract a digit from 9. 9 minus 3 is going to be 6. And then blue is going to be multiply the digit by 2. Well, in this case, it's 0. Anything multiplied by 0 is going to be, of course, 0. So these are now our numbers after the changes. So now let's sum up all of these numbers. So in this case, 3 plus 6 plus 9 is going to be 18, or simply column 8 here. And one important thing to note is that the row 0 is at the bottom and the far right for the column. So what we're going to get here is we're going to get a formula of 2 different meanings. So in this case, we've got I times R. So I is the number of indicators, but important to note is that the lit indicators are worth 2 and the unlits are worth 1. And the R means the row number. So our row number, for starters, is 5. So we're going to do 5 times, and whatever we get for the indicators. So we have 1, 2 for the lit indicator, and that is going to be 3, 4. So 5 times 4. That's not what I meant to do. So 5 times 4 is going to be equal to 20. And we're simply going to use the least significant digit of this result, which is simply going to be 0. And we're going to be using white as our color over on the right side here because we're using row 5. And this is going to be the color that we use right here, so white. So now, let's do the math here. White wants us to use the vertically adjacent digit on the keypad. So in this case, 0 is vertically adjacent to 5. Therefore, this is going to be 5. And this is going to be our number for the final stage here. So 305, 960.
Is the right answer.
And just like that is a solved module. Now, one thing I will note is that I'm probably going to be messing around with some of the button noises, for example, later on, or maybe some of the sounds. It's still very much a work in development with regards to some of the cosmetics. But overall, that's all there really is to this module. That's all I really wanted to explain. And one important thing is that use the least significant digit and or the absolute value of this total. In this table, what we need to do is if we happen to get a negative value, because some of them happen to have subtractions, for example, you want to use the absolute value of that total. So just make sure that you use least significant digit and or absolute value of that total. Very important to note that down. So let's take a look at one final example. This module is very straightforward to do, and most of the rules make sense. So let's take a look at this last one. So we've got white. We're going to use the vertically adjacent digit on the keypad. 2 is vertically adjacent to 7. 8 is vertically adjacent to 3. Blue is multiply the digit by 2. 2 times 2 is going to be 4.
Absolutely right.
Now we meet gray. So we've done all of the other colors except for gray, and gray is a bit of an interesting one. For gray, it's going to be multiply the digits by the sum of all visible digits. And the reason why it says all visible digits is in this case, it can appear on stage 4, and we're not going to include the question mark in this equation. Now, of course, one other important thing that I should mention is that this does include itself as well. So in this case, we're going to sum up 2, 9, 4, and 0. And this is going to be, let's just pop out our handy dandy calculator real quick. We've got 2 plus 9 plus 4, and obviously 0 is nothing. So then we're going to do 15, and we're going to multiply that digit by the sum of all of the variables. So here. So we're going to do 15 times this by 2 is going to be 30, and we're simply just going to use the least significant digit, which in this case is 0 for that number. And that's all there is to gray. So gray is probably the most complicated of this alternation here, but just make sure that you note down that it actually does include itself as well. So red is going to leave the digit as is, orange is going to be multiply the digit by the number of batteries. In this case, we said that that was 0, so we're going to simply mark that as 0. And white, 0, use the vertically adjacent digit on the keypad, which in this case is a 5.
That is absolutely right.
Okay. We know for a fact that the oranges are going to be zeros in this case. 1. So we have a series where we have 2 grays here, and we want to actually probably keep the sum of these, the total sum of these down because we have 2 grays on the module here to make our life simple. The 4 plus 1 plus 7 plus 9 plus 4 is going to be multiplied by 5. 1 times 5 is going to be 5, or in this case, 25 modulo 10, 5. Then we're going to do 0 again. Green wants us to add 1 to the digit. So in this case, we're going to add 1 to 9, which is going to be 0. And then for 4, 4 times the 25 here is just simply going to result in 0.
Is the right answer.
Okay. And finally, now we're at the last little bit here. So our row for this is going to be 8 plus 2 plus 1 plus 8 plus 3. The 8 and 2 cancel each other out. 11, 12. So row 2. Now we're going to do the changes here. So let's take a look. Orange, we said it was going to be 0. Green is going to be adding 1, so that's going to be 3. Cyan is going to be subtracting 2, so that's going to be 9. Red is going to stay the exact same, and purple is going to be subtracting the digit from 9. So 9 minus 3 is going to be 6. Okay. So now, let's add up all these guys here. So we've got 3 plus 9 plus 8 plus 6 for our column is going to be a 6. So we have I plus R in this case. So the row number is going to be 2, and we're going to be adding, it should have been 4. 1, 2, 3, 4 for the lit indicators. So yeah, 2 plus 4 is going to be a 6, and we're going to use the color of green, which will give us 6 plus 1 is going to be 7. So 7 is going to be the place of our question mark. 073 986, and just like that is a solved module. That's all there really is to it. It's a very simple module to do, and I hope you guys enjoy this a lot. I probably am going to start making some more modules. I think that that'd be very cool to see what people think. And as always, thank you guys for watching. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye.